for coming to today's Kinesis session. For those of you who are motivated enough to get up this early, appreciate that. My name's Ray. I'm the product manager for Amazon Kinesis. And today co-presenting with me is Alan Lewis. Alan is the principal architect at realtorcom. So I'm very excited to have Alan here today to share with you guys a real-world use case of streaming data and Amazon Kinesis. So for the first half of the session, I'm going to cover some basics about streaming data scenario, give you an overview of the services we offer here at Amazon Kinesis, and then go a bit deeper on one of the services we offer, which is called Kinesis Firehose, so that you can get a sense of how easy it is to get started with streaming data. Then for the second half is the more exciting stuff where Alan's going to share with you guys how Realtor.com has been leveraging streaming data and how Amazon Kinesis has transformed the way they use their data. So before we kick it off, so what is streaming data and why does it matter? So streaming data is a mechanism where you collect, store, and analyze and use your data in a continuous streaming manner as compared to a traditional batch-oriented way, which often involves hours or days of latency. Now you get that in minutes, seconds, or even milliseconds. So that's what streaming data is. Then why does it matter and why should I care about it? It all comes down to one essential reason is sometimes you just need to go a little bit faster than what you do today. Now I'm not necessarily claiming that Kinesis is going to save you in this particular situation, but it does provide a whole lot of benefit in certain scenarios and very often. For example, if there's an issue on your application servers or web servers, you don't want your system admin to see that error and be able to analyze the log right away, right after the issue has occurred, but not like hours later or days later. Or if you launch a marketing campaign online, you don't want your marketing manager to be able to monitor the performance of the campaign right after you launch the campaign, but not a day later when he or she sees the report. That's often too late to take actions to fix the issues. So that's why we care about streaming data, and that's the value we can add with the streaming data. So we do see adoptions from customers across different industry segments for different use cases, use different data in a streaming manner. But we often see customers streaming data journey through 3 different phases. So the first phase is what we call accelerated data ingest, transform, and data load. So in this case, that's the entry point into the streaming data world where people still use and analyze the data in the data stores with the tools they are familiar with. For example, S3, Hadoop job, relational database, search engine, business intelligence tools. These are the tools people have been using for years, are very familiar with. However, what streaming data can bring to the table is instead of having data appear in these places every hour or every day, now you get that in minutes or even seconds frequency. Then people moving to the second phase is what we call continual metric extraction. So what it does is you ingest all your data as a continuous stream. At the same time, in real time, you extract metric, gain insights, analyze the data out of the data stream directly. And at Amazon Kinesis, we have particular services catering for these different scenarios. Then we move into the third phase, which is really more sophisticated use case of streaming data. We call it responsive data analysis. A good example will be in the mobile gaming industry, where you distribute your games to your game players. And as they play the game and they interact with the game, you constantly collect these interaction events in real time and then analyze them. So depending on the way your gamers engaging with your game, you'll feedback in real time back to your game experience, so that way you can provide a more engaging experience to your gamers. So these are the very typical 3 phases as we see people going through the streaming data journey. At Amazon Kinesis, we offer a variety of different services to cater to these different scenarios to help you get started with the streaming data journey. The first service we have at Amazon Kinesis is called Kinesis Streams. It was the first service we launched about 3 and 4 years ago. So Kinesis Stream, it stores the data as a continuous stream. And it enables you to build your own customer applications to process the data in whatever way you require. So if we recall the previous slides, Kinesis Stream is actually targeted for more sophisticated use cases, which is the third phase I mentioned in the previous slide. It's fully flexible. You decide how you're going to collect your data, how you're going to partition your data, how you're going to read it and process your data. Then we have this second service called Kinesis Firehose, which we launched at reInvent last year. So Firehose is a service that delivers your streaming data into destinations in real-time manner. Today, Firehose support Amazon S3, Redshift, and Elasticsearch service as supported destination. And you can probably tell it fits well for the first phase of the user adoption cycle I mentioned in the previous slide. So you still use and analyze the data in the tools and the data stores that you're familiar with. But instead of waiting for the data to show up hours later or days later, now you get that in minutes or seconds. Then we have this third service. It's still in preview right now. We pre-announced at reInvent last year. It's called Kinesis Analytics. What it does is it allows you to write standard SQL against the data stream. So basically, you write a SQL, perform an analysis, not against the relational database. You write a SQL to query and analyze data against the real-time data stream. So that fits well for the second use case, the second phase of the adoption cycle I just mentioned in the previous slide, which is data streaming, data insights, the data analysis against the data stream. So it's in preview. If you guys go to our website, check it out, you can sign up and play with it. So as you can see, Amazon Kinesis is a platform for streaming data. We offer a variety of services and capabilities. So depending on where you are with your streaming data journey, what is your use case, you can always find a right fit for you at Amazon Kinesis. So let's go a bit deeper to Kinesis Streams. You recall it stores the data as a continuous stream, allows you and enables you to build your own application with your own tool to analyze and process your data. So look at this graph on the very left-hand side, which is what we call data producers. So you configure your data producers. It could be hundreds or thousands of data producers, being application servers, mobile devices, to continuously push data into your Kinesis stream. Then on the right-hand side, you can use a tool of your choice. It could be Kinesis Client Library. It could be Spark Streaming, Storm, to read the data out of the Kinesis stream and process it with your own custom logic. So you have full control of how the stream is going to be organized, how you scale the stream, how you should partition the data, how you should read the data, and how you should process the data. It's fully flexible. Then a bit about Firehose. If you look at this diagram, on the left-hand side, it's fairly similar to Kinesis Streams. You configure your data producers to continuously push data into the Kinesis Firehose. However, on the right-hand side, it's a bit different. You don't need to write a single line of code. You don't need to write a custom application. Firehose automatically delivers data into the destination that you configure. Again, today we support S3, Redshift, and Elasticsearch. So all you do is you push the data into the Firehose delivery stream, then we automatically manage the rest for you. You just sit there and wait for your data to show up into these destinations seconds later or minutes later, depending on your buffering configurations, which we will cover a bit later on. So then we'll go a bit deeper on Firehose. The reason is because Firehose, as I mentioned, the accelerated data ingest, transform, and load, that's the entry point to streaming data. And we built Firehose for that exact reason. It's real easy, which I'll show you a little bit later on, see how easy it is to use the service and to getting started with the streaming data. So we'll go to the Kinesis Console. So all Kinesis services will be live in the same Amazon Kinesis Console. So if you go to AWS Console, click on Amazon Kinesis. Today you're going to see two services, Streams and Firehose. In the very near future, you're going to see Kinesis Analytics here as well. So you click on Firehose Console, then you'll see this page. Look very familiar, typical AWS Console UI. First, let's talk a bit about Amazon S3 destination. So what do you configure? Step one, you pick S3 as a destination and configure a delivery stream name and choose an S3 bucket that you own for us to deliver the data into. Optionally, you can configure a prefix. So in case you use the bucket for multiple purpose, we'll basically add this prefix into the objects we deliver to your S3 bucket so that you can distinguish for your downstreaming workflows. Step two, couple of configuration options. The first one is buffering. So Firehose buffers streaming data in micro batches before we send it to S3. That way, it's more efficient to load data into your S3 bucket, and it's more cost effective for you. Buffer options can be configured around two different options. Either you can configure buffer size, which is in megabytes, or you can configure buffer interval, which is in seconds. So you can configure both options, and whichever option satisfies first will trigger the data delivery to your S3 bucket. Optionally, you can configure to let Firehose to compress your data before we send the data to your S3, or you can configure an encryption option where Firehose will invoke a KMS key that you own for data encryption on the S3 side. And then we have this IAM role for security control, so you explicitly allow Firehose to access your S3 bucket, and no one else within AWS is going to be able to access your S3 bucket other than the Firehose service principal. So afterwards, you click on Next, you review all the configurations, click on Finish, and it's as easy as that. So 30 seconds or maybe 60 seconds later, now you've set up a streaming data pipeline. All you need to do right now is to have your producers to push data to Firehose, then the data is just going to continuously show up in an S3 bucket. It's as easy as that. Now, RASH of Destination. So the way Redshift works is Firehose will still deliver the data to S3 bucket. Then we'll continuously issue a copy command to load the data from your S3 bucket to your Redshift cluster. There are two reasons for doing this. Number one is loading data from S3 to Redshift is still the most efficient way for us to load data into Redshift today, so that we make sure it doesn't consume much of your resource on the Redshift side, so that you can continuously to run your queries of complex analysis against your Redshift tables. The second reason is, for whatever reason, your Redshift cluster is not accessible. For example, if your Redshift cluster is on a maintenance, or you're doing an upgrade, or maybe you're changing your database schema, then we always have a place to hold your data. So you never lose any data. We always have a copy of your data in the S3 bucket. And for certain use cases, actually, people use Redshift for analysis. They also want to have a copy in S3 for other different purposes. People might run a Hadoop job against these objects. So we offer that capability for you. And configuration-wise, as you can see, other than the S3 options, apparently you're going to have to tell Firehose what's your Redshift cluster database table name you want us to load the data into. You can also configure Redshift copy options for more customized data load into Redshift. So that is Redshift. Actually, again, it's fairly simple. After you click on Finish, now you've set up streaming data pipeline into your Redshift table. Then lastly, it's the Elasticsearch Destination. We launched Elasticsearch Destination back in April during the Chicago Summit. So again, fairly similar. You configure your Elasticsearch cluster, tell us your index name and type name. Firehose can also do index rotation. For those of you who are familiar with Elasticsearch, it often doesn't serve as a long-term permanent storage. So often people rotate the index over time, so you can retire the older ones over time and only keep the most fresh one. So Firehose can rotate the index in hourly, daily, weekly, and a monthly manner. You can just configure that. Then we have this backup option. To back up your data to S3, there are two options you can configure. You can either choose to back up failed documents, or you can choose to back up all documents. When you pick failed documents only, what happens is if for whatever reason we're not able to deliver data to your Elasticsearch cluster, we'll automatically send it back up to the S3 bucket, so that you know, hey, what are the documents that haven't been delivered to my Elasticsearch cluster, and you can backfill later on. Or you can enable all document backup, which essentially triggers two concurrent flow. One flow, we continuously streaming the data into your Elasticsearch index. And the second flow is we continuously deliver the same data into S3 bucket. Again, oftentimes we see customers have two different use cases. One is I want to leverage Elasticsearch for some real-time dashboarding through Kibana, or some real-time search for anomalies. But at the same time, I have more complicated analysis with my Hadoop job. So I also want to keep a copy of my data in S3 where I can run my EMR job. So it is as easy as that. These are the configurations for Elasticsearch. Again, 30 seconds or 60 seconds later, now you've got a streaming data pipeline that scales elastically to send data to your Elasticsearch cluster in real time. So as you can probably tell, the objective of Firehose is really, we try to abstract away as many things as possible from you, so that it's as easy as for you to get started. But normally the downside of doing that is then you lose some sort of transparency and a visibility into what's going on behind the scene. Now, to compensate that, Firehose offers a lot of monitoring capabilities so that you still gain a lot of transparency and visibility into what's going on. We offer many CloudWatch metrics where you can clearly monitor and see your data flowing from your data producer to the Firehose service and how Firehose delivers the data into your destination. You can see how many bytes of data have been delivered and transferred, how many records have been delivered and transferred, if there's any failure or not. So that's the metrics, and if there's any failure, we also log the error message through CloudWatch logs. So, for example, if for whatever reason we're not able to deliver data to your destination, we'll log an error message to your CloudWatch log group so that you can clearly see what's going on. So CloudWatch Metrics tells you what's going on, are things working or things not working, and these error message helps you to troubleshoot the issue if we figure things are not working for whatever reason. So this is monitoring. Lastly, I'm going to touch a bit on, very simple, touchly on pricing. Again, pricing is fairly simple, one dimension, nothing else. We charge 3.5 cents for every gigabyte of data that you ingest through Firehose. So it's fairly predictable for your cost. As long as you understand how much data you're going to send through Firehose, then you have a clear understanding of how much it's going to cost for you to run the streaming data pipeline on Firehose. So this is from my side. Now we have more exciting stuff from Alan. He's going to share with you guys how realtor.com has been using streaming data in their company. Please join me to welcome Alan to the stage. Alan? Yeah.
Good morning, everyone. I'm really excited to share with you today what our experience has been using Kinesis to build a particular product at realtor.com over the last few months. So a few days from now, or even a few hours from now, you'll probably have forgotten most of what you heard here today. So recognizing that, I wanted to state up front, what are the key takeaways that I would like you to remember above all else from this session? In my experience, Amazon Kinesis has been simple, reliable, and it's offered great performance. I consider it to be a transformative building block with broad applicability. You can use it in all sorts of ways, and I'll demonstrate what that means throughout the talk. And last, it's a building block that's an enabler for what I call real-time everywhere, which is something that I think many of us are striving for today. A little bit about realtor.com. I don't presume that you know much about who we are, so I wanted to tell you a little bit. Realtor.com was the first national US real estate search site. In fact, we're celebrating our 20-year anniversary this year, so we've been around a while. We pride ourselves in having the most accurate real estate content, very important if you're looking for homes, that you have up-to-date data there. We get data from 99% of MLSs in the US. MLSs are, if you don't know, the place where most real estate listings originate in the first place. So we have breadth and we have scale. We have 55 million unique users just to realtor.com alone in the month of April. Our cloud strategy has been really to go all in on cloud. We want to shut down our data centers. And we're well underway in getting there. And most of that investment has gone into AWS, and we're very happy with our experience thus far. And we're about midway through, so we have major systems already serving traffic in production out of AWS, including big parts of our BI infrastructure, our search infrastructure, our geo services, photos, and more are all in AWS today. And the rest of that stuff is well underway in development. And our approach specifically has been to have a strong bias towards AWS managed services. So we love EC2, we love writing code ourselves, but we also want to use the most of the managed services, things like Kinesis, like Redshift, to take a lot of the administration work out of our hands so we can focus on those things that really provide the value add for us specifically. So the example I'm going to talk about today is a new product that we launched a few months ago. But first I want to walk you through the customer problem so you really understand why we built the product and what were the constraints that we were facing. So if you think about, if you're a real estate agent, you have all of your listings on realtor.com, and you get a lot of visibility. You get a lot of interested buyers for your clients through this portal. But those listings, they get a lot of traffic at the start when something is first listed, but that decays over time because the default sort is most recent first, just a natural thing where you get a lot of traffic up front. Now, if you're an agent, you could buy more exposure for your listings, but you really only want people who are interested in those listings to see them. You don't want people who are searching in Palo Alto to see listings from San Jose. And if you're an agent, you also might want to get more brand exposure in search. So this was the problems that we wanted to solve with the product that we launched. So the product is called, it's the Turbo Listings product. It's a native ad product that allows customers to purchase more exposure for their listings in search. But that exposure will be 100% relevant. So you can't buy your exposure for your listings outside of the area they're actually in. So it's a 100% relevant ad product, which is a difficult thing to do. And we're very proud of having built that. And a particular thing it allows you, as you see here, for agents to get their profile photo in search, which is another value add. So the requirements of this product in sum meant that really it was going to be really difficult for us to use an off-the-shelf ad server to build this product, which means we're really faced with having to solve these problems ourselves. And so the broad technical requirements here is this is an ad product. It's being put on a site that has immense scale. So we really have we have to have something that handles the extreme throughput and has to be available 24/7. With where we're at in our cloud migration, where we have systems sitting in AWS, we have others sitting in our data centers, and our AWS build-out includes a lot of different VPCs, a lot of different security requirements within that. We needed something that was really flexible so it worked within this hybrid state that we're in currently. And in particular, it's a paid product, so we needed this data to flow into an auditable, secure billing database. I'll talk about that a little bit more later on. So faced with these requirements, why do we choose Kinesis? So we knew from previous experience, just from experimenting with it and using it on smaller projects, that it has great performance. We knew that up front. But in this particular case, we really liked the multi-producer, multi-consumer model. That's something you'll hear a lot about or see if you read the documentation of Kinesis, this concept of data producers, things feeding data in, and data consumers, things pulling data out of the queues. And we chose Kinesis because it is a worry-free managed service, so it fit the bill with our overall cloud strategy. So here's the overall simplified architecture of this product, and I'll pause here for a second and walk you through so you can understand how the data flows. So most of the data flows here is left to right, and the data in this diagram is impressions data. So ad impressions originate from our front ends, both from our web front ends and from our native mobile apps. So that's a realtor.com website, our native apps, and that data flows through their respective backends. And then those backends, these are now server-side, are feeding data into the Kinesis streams. These are the data producers. And then we have multiple systems that are pulling data out of the Kinesis streams on the right. So the one in pink there in the middle, it's the campaign manager. I'll go into that in more detail. And we also have our billing flow, which is separate, and that's pulling data out. These are the data consumers. And then downstream from there, that data flows into other systems. It goes back into a search backend, and it goes into other systems like our sales system, enterprise reporting, billing, and so on. Okay? So what about the data itself? So the data going into the streams is the impressions data. And this is an example of an impressions data, and it's very straightforward and simple. And this is what we strive for, is simplicity in the data so we can be used in all sorts of flexible ways downstream. So an impression in this context, it's a set of name value pairs, starting with the campaign ID. What ad campaign is the impression for? What's the unique ID of the impression itself? Who is the customer of the ad campaign? Where did it originate from? Some more metadata about the application. And then some metadata about the user. And this helps us do things like scrape out bot impressions, so we're only charging for real user impressions. A little bit more about one of the two data consumers. And this is a systems diagram of what's called the campaign manager. So on the left, you have the Kinesis stream, and you have a Lambda function pulling data out of the stream. And then it's posting each impression event to a web service sitting in EC2. And that web service, the campaign manager is a set of web services that encapsulates the logic for the lifecycle events of these ad campaigns. So each event that gets posted then gets decremented from the right campaign. Now the campaign manager is not storing the details of each impression. It just wants to decrement each impression from the correct campaign. And on the right there, in this case, it happens to be a Postgres database managed by RDS. That's what holds the current remaining impressions for each campaign. The second data consumer is a little bit more complicated, and this is the billing flow. So the target here is to get this data into Redshift. And that Redshift database contains the full details of each and every impressions, both for auditing and for billing purposes. We only charge for impressions delivered, and both ourselves and for third parties want to make sure that record is auditable. And it's kept secure. It's isolated, it's SOX compliant, so it's in a private subnet. So in order to work around this, we did have to build out some more systems to get data from Kinesis into Redshift while keeping the data encrypted along the way. So the target here from Firehose is to pipe data from the Kinesis stream into S3 in an encrypted state. And then this control flow, which is powered by Lambda, by Dynamo, and by the AWS Key Management Service, is what helps keep the data encrypted so that by the time it gets into Redshift in the private subnet, it's in an encrypted state. So I won't go into detail there. Happy to talk about the specifics after the talk. But all this infrastructure was to solve that problem of keeping data encrypted by the point it gets into Redshift. And something else to notice here is this is entirely serverless. It's completely buzzword compliant. So all the logic is kept within Lambda functions, and we're using AWS services along the way. A little bit more about Redshift. So Ray talked about how you can configure data in batches. So this relies on that configuration of data being put into batches in specific increments in S3. And then we can change that batch size. So this shows that this is pulling data into Redshift in 15-minute increments. So every time we notice that there's a new file in S3, then that gets picked up and gets piped into Redshift. We can change the frequency by just changing the configuration on Firehose, and then we don't have to change anything else. Every new file that gets put there will get put into Redshift. We don't have to configure the timing at any point other than the configuration on the Firehose console. A little bit more about the outcomes. So we were able to achieve huge scale here. So we're serving millions of impressions per day on just 2 Kinesis shards. So it's very cost effective. But we've tested this up to 20 times our current site traffic. And basically, we weren't able to break it with the load testers we had. So we're very confident we can scale well beyond our current site traffic. And we're getting great performance. So the graphs on the upper right show you both the put and get latency that we're getting from Kinesis. So it's in the low tens of milliseconds there. We're very happy about that. But we do batch events as demonstrated for efficiency. So we minimize our costs there. And for the case of billing, we only do daily billing runs right now. We don't need that to be up to the minute accurate. But for those use cases, like for customer reports, those are fed off of the campaign manager streams. Those are in near real time. So this is all configurable based on our needs. So in summary, for our purposes, Kinesis does give us real-time data streaming, which we're thrilled by. To summarize some of the lessons learned, so as demonstrated in the billing flow, there is some complexity today with getting data into Redshift from Kinesis if you need it in an encrypted state. But we were able to work around that, and so it is doable even today. Ray didn't touch on the aspects of how data is can be duplicated in Kinesis. This is not a common occurrence, but you do need to work around what do you need for deduping data from Kinesis. So for our billing purposes, we never wanted to double bill for an impression, so we did have to consider that and make sure that we deduped data via Redshift. Not every application needs, or applications have different dedupe behaviors, so just think about what you need and plan accordingly. The simple key value data structure that we have in Kinesis is already paying dividends. We're able to analyze data really well, and this sets us up for using things like the Kinesis Analytics down the road, which will handle key value data structures very well. So the future for us is a real-time pipeline. We've done it in this particular product, and this is a model that we're using down the road. So Ray and I didn't coordinate pictures, but I like to think this is the same mountain where the bicyclist is being chased by the bear. So our goal is, overall, that we can collect data on page 1 and act on that data by the time the user gets to page 2. So seconds later, we're able to analyze vast amounts of data, act on it, do things like provide recommendations, customize the experience for users. And this technology and others provided by AWS really set us up to do that. So to reiterate the takeaways here, in my experience, Kinesis is simple, it's extremely reliable, and it offers great performance. It's a transformative building block that can be used in all sorts of applications. You just heard about one today, but you can imagine using this in all sorts of ways wherever you need to stream data. And it's an enabler for real-time everywhere. For me, with what we have today, I've now flipped my thinking to assume real-time first rather than assume batch. So real-time is the assumption, and then I only batch where needed. It's a real mind flip. Finally, we're hiring. If you're a software engineer, product manager, QA engineer, data scientist, pretty much anything, come and talk to me after the show. Hit me up on Twitter. Would love to talk to you. We have offices here in Santa Clara, just across the freeway, and throughout the US and Canada. And thanks to Eddie, Viren, and Sonal who helped me put together this talk. So invite Ray up. We're happy to take Q&A here publicly or after the show. I know we have a mic here. Happy to hear from you. Thank you.
Right. Thanks, guys, again. This concludes our session, and hopefully all of you guys have got a pretty good sense of what streaming data is, how you can use streaming data, and what are the offerings we have here at Amazon Kinesis. And also, hopefully, you'll get a lot of inspiration from Alan's real-world use case and see how that might, streaming data might fit into your own organization. So we'll probably hang around for a little bit here.
And we have plenty of time before the keynote for questions. I think we have a mic here if you want to step up to the mic so others, both live and on video, can hear your question.
Yeah, go ahead.
I have a couple of questions for you. You showed your high-level architecture diagram. You used the stream as well as the Firehose.
Yep.
Going back to the diagram, I mean, why didn't you use your Firehose and streaming, during the data ingestion instead of, unless there is something your Lambda function is doing? Why not at the same time you're sending your data to the stream as well as the Firehose?
So
why is
right? So Firehose picks data off of the stream. So there's one place that data is sent.
Right.
And because of the multi-consumer model, we can have like a Firehose pulling data off the stream. I didn't mention if you're asking about, well, why do we have Lambda sitting in between Firehose?
Right.
So in this, thank you for mentioning that. So in this particular case, the job of this first Lambda function is to validate the data. So we can't guarantee, just because there's no guarantee that we don't have a bug in one of the data producers, that there's malformed JSON at the point it enters into the stream. So that first Lambda function in this flow here its job is simply to validate that it's valid JSON. That's it. So that we don't corrupt data by the time it gets to Redshift.
Coming to that question again, why didn't you validate before going to the streams?
We do.
Oh,
but
okay.
It's a matter of protecting downstream systems from bugs that could occur before data hits the stream.
Would you mind telling what is the frequency of your data per second?
Very fast.
Have you experienced any throttling before while writing into Kinesis stream?
I'm sorry?
Have you faced any throttling? There are limits when you're writing into Kinesis stream.
Right.
And since you're using 2 shards, that's the reason I asked what's your frequency per second.
Right. So those shards are reasonably saturated, but as part of the testing we did, that testing involved increasing the number of shards, making that dynamic and testing that our scale overall, as we hit it with larger scale, that we could increase the number of shards. So we're very comfortable with the capacity at the two shards, but we also know that we can over time increase the number of shards to handle even more data. So I think we have some other people asking questions behind you, but happy to talk more after the.
Sure. Okay.
Thank you.
So one question with how it handles the data going in and out. We were talking to somebody wondering if Kinesis is HIPAA compliant. Does it store the data anywhere? Is it just generally encrypted as it's transferring it over the wire, or how does that behave?
Yeah, so we're not HIPAA compliant yet today, but we are actively working on that compliance. All the communication on the transport layer is HTTPS, so it's encrypted there. However, on the rest, it's not encrypted today. But you can always choose to encrypt the data beforehand using KMSK or whatever tools that you want to use for the encryption, so that even before the data gets to Kinesis, it's already encrypted.
Yeah, that's what I was thinking. Thanks.
My question was about, trying to get the picture here. There's a certain flow here.
Actually, if you could step a little closer to the mic, please.
The impression tracking flow.
Mm-hmm.
If we can go back to that picture. So here you have a Lambda pulling data from a Kinesis stream. My question is, why is this not serverless, and why is there an Amazon EC2 instance?
Yep, great question. So the campaign manager itself, which is actually best demonstrated by this diagram, impression tracking is only one of its jobs. So it's responsible, so that area in pink, that is a Ruby on Rails app. that has multiple web services exposed to handle all aspects of the life cycle events for ad campaigns: creation, deletion, impression, decrementing, and so on. So the logic of there, it's at the moment a bit too complex to say we're going to spread that across half a dozen or more Lambda functions compared to encapsulating that with an application that it's fully tested and it's self-contained. In this case, in the diagram, the reason why there's a Lambda function between the stream and the campaign manager is we wanted to keep the campaign manager entirely web services based. So that Lambda function's job is simply to pull data off stream and post data to web service. We could have taken the campaign manager and used the Kinesis client library to pull data off the stream, but then we have something that's not entirely web services based. Like there's multiple ways the data can come in. So it's really just to keep architectural purity with that thing, given its complexity and wanting to generally expose functionality through web services.
Would you envision maybe someday rewriting that to be serverless, or if you were to do it from scratch?
Certainly. I think we're very happy with the serverless model for the kinds of jobs that we're doing within the flow. I mean, obviously, like here, we're using it in a lot of different places. But I think it'll take some time for things to mature a little bit for us to tackle more complicated workloads entirely serverless.
Thank you.
Yep.
So I have a question for the Firehose thing. Do you have any plans to have different formats of file, like Parquet or Avro or something, and also at the same time support like high partitioning of the data, so we can use better tools on top of that instead of kind of adding more and more tools on top of S3?
Yeah, good question. So we are actually, we got many customer feedback around the same line. So the objectives, as you can see, what Firehose does is to make it as simple as possible to enable your downstream processing. So very typically, once the data lands into S3, you are very likely to run a Hadoop job, right? So you want to make sure it's high partitioned. We support different Parquet format or Avro so that it's easier for your downstream Hadoop job. And we are actively working on these things to make sure that as we transfer the data into S3 bucket, we do some pre-processing so that once the data is in S3, it's much easier for your downstream Hadoop job. Yeah.
Going back to the previous slide, you chose Postgres as the RDS.
Yep.
What were the reasons for choosing Postgres versus why not go with DynamoDB?
Right. So a lot of reasons. One, so we are using multiple database engines in our AWS migration, so we don't just pick one. This particular system, our experience Postgres is really great at decrement operations, so it's very fast there, and its job here is very simple. And the team that happened to build the system has a lot of experience using Postgres, so the combination of all those, it was a very good fit here. It's entirely isolated, so because the system as a whole is web services based, the database here is entirely self-contained within the system. There's no outside systems pulling data from the relational database in this context.
Thank you.
Yep.
Hi. Thanks for the presentation. Really quick question. So you talked about some challenges with the VPC. Were those around AWS Lambda running on VPC?
It was specifically, it was a specific challenge about the private subnet. We haven't run into any challenges with the VPCs itself. And I know the services are adding a lot of native capabilities to play nicely with VPCs. So what was demonstrated in the billing flow was really just particular to the data being encrypted and having to traverse the private subnet boundary.
Got it. And just one other question on Kinesis and Firehose for both of you. So, you have the Kinesis stream, and I saw you have the AWS Lambda that then goes into Firehose.
Yep.
Why not just use Firehose, send data into S3? We're facing the same situation. We're a payments company. We're looking at, do we really want to use Kinesis, or do we just take the storage that we get with Firehose and then have Lambda running off of S3 when the data gets there? Can you just highlight that, because I feel like that's something that every one of us probably want to know.
So I think we were using Kinesis just as a baseline because there were multiple consumers of the data, not just Firehose. So we weren't just using the batch case. But Firehose, it really did its job here of taking summary data off of Kinesis and putting it into S3 buckets. And we couldn't go directly to Redshift from Firehose because of the data encryption issue and getting data into the private subnet.
Okay, thank you.
Yeah.
I have a couple questions with Firehose.
Sure.
To my understanding, Firehose is for one Redshift, one table, and one other thing. But are there any plans for making it be sending multiple data to different Redshift or have multiple tables with different copy commands instead of producing the same exact Firehose but with different copy commands?
Yeah, so that's also a feedback we hear from many customers. We are actively working on these things. Like basically today, as you mentioned, one Firehose delivery stream sends data to one bucket, one table, and one Elasticsearch index. We're working on something that allows you to go to multiple different entities of the destination. But for now, for most of the use cases, if we're thinking about, say, 5 or 10 buckets or 5 or 10 tables, you can just easily work around that by having multiple streams. You can basically partition your data at each of the Firehose delivery stream.
Okay, thank you.
Great. If there's no other questions, Ray and I will be happy to chat afterwards. And thank you again for your time.
Thanks again, everyone.